All right, gentlemen. So I'm going to go over the IA review homework. This is not due until Wednesday. And the reason I'm giving you this homework is because as I was reviewing some of the objectives that we're going to be testing on the IA, I realized that this is one objective that I just haven't seen a lot from you guys, and I haven't seen a lot of mastery over the objectives of proportion and constant of proportionality and finding out if things are proportional and unit rates, yada, yada, yada. So we're going to go through some of this together. You're going to do some of it on your own. Again, it's not due till Wednesday. And I'm going to put a link to the Khan Academy videos on proportionality. I highly, highly, highly recommend them. They will be very, very helpful, and you will come in much more prepared. Let's take a look at this problem. So because the moon has less gravity than the Earth, a person will weigh less on the moon than he or she will weigh on the Earth. The graph below shows this relationship. Use the graph to answer questions 1 through 4. Okay, so I know I'm going to use this graph. And when I have a graph, this is kind of my key information box so far. So because the moon has less gravity than the Earth, a person will weigh less on the moon than he or she will on the Earth. Okay, so in this one, I know that on the moon, you're going to weigh less than on the Earth, okay, because of gravity. And I can take a look here, at this graph. Some of the points that I have 0, 0, which is a point. It's going to disappear. I don't know why this does that. Which is a point. I have 90, 15, and I have 180, 30, and then up here I have, it looks like 270, 90. Okay, so the first thing I'm being asked is, what is the constant of proportionality? And I remember that my constant of proportionality formula is K equals Y over X. All right, so I'm going to choose a Y, I'm going to choose an X. Obviously, I'm not going to choose 0, 0. Okay, so I'm going to choose the lowest one. If this is 90, 15, okay, because this is my x-axis and this is my y-axis, then I'm going to put my 15 over my 90. And it looks like they simplified that in my answer choices down here. So I am going to put this down a little. So I'm going to simplify 15 over 90, and I'm going to get 1 over 6. Okay, so my constant of proportionality here is 1 over 6. That's A. 1 over 15 is wrong. 6 would be the sort of distractor, right? If I had switched my x and my y, I would have gotten 6 over 1. So that one would be probably the most common mistake. All right. Number 2, what do the coordinates in the ordered pair 90 through 15 represent? 90, 15 represent. So when we have these ordered pairs, they mean something. What is the sentence that I can say that would essentially tell me what this means when I see 90 in my x and y in my 15? And so I'm going to take a look here. And I know that my x-axis is my weight on Earth. My y-axis is my weight on the moon. And so now I know that because this point here is telling me if I weigh 90 pounds on Earth, I'm going to weigh 15 pounds on the moon. So I'm going to look for a sentence that means that. A person who weighs 15 pounds on Earth will weigh 90 pounds on the moon. Well, that seems to have switched, right? So we know that that's wrong. Person who weighs 90 pounds on the moon will weigh 15 pounds on Earth. Well, this is the same mistake, right? We've switched the Earth and the moon, and we just said it in a different way. C, the constant of proportionality, which is 15. Nope, that's not the constant of proportionality, and that is not what that means. D, a person who weighs 15 pounds on the moon will weigh 90 pounds on Earth. Well, I had just said a person who weighs 90 pounds on Earth will weigh 15 pounds on the moon. This is basically the same thing. I mean, it is the same exact thing, just being said in a different order. So my answer here is D. Moving down, what does the point 0, 0 represent in terms of the graph? A, weight cannot be measured on the moon. Well, I know that's false just because the intro told me that that was false, just because I have this graph that tells me a bunch of weights on the moon, right? So A is totally wrong. If a person weighs 0 pounds on Earth, they will weigh 0 pounds on the moon. This feels true, All right, I want to read the rest of my options. If a person weighs 0 pounds on Earth, the constant of proportionality is 0. Nope. If a person weighs 0 pounds on Earth, it is impossible to predict their weight on the moon. Again, we know that that's not true because I have a whole graph here telling me what you weigh on the moon based on what you weigh on the Earth, okay? So my answer here is B. And then when I have unit rate, the coordinate, which coordinate pair represents the unit rate? And so for my unit rate, I'm just going to go with my constant of proportionality, right? So I already know that my K is equal to 1 over 6, okay? And that means that for every 6 pounds on Earth, I have 1 pound on the moon. Because I have this one here, that is going to be my unit rate. Okay.